Okay, for this one, I just brought this down because we're going to need to refer to. So the relative risk, comparing the risk of NCEA for participants who learned a musical instrument for 4 years, who didn't play any music, to those who didn't play any music, is 0.708. So we're comparing two um, risks to each other, relative risk, comparing two risks. So we're going to be comparing this rate, this over this, with this, and we don't know what this is, to this, but we know that when we divide this one by this one, we're going to get the number that they have here, and we're going to solve it that way. So it's going to be 85 over 346 over however many that we have alpha over 346, and I made a mistake here. It shouldn't be 386, should it? It should be 258. 258. Yes, really tricky. And we know that when we hit that order, we get 0.708 because they say so. Oh, okay. Good luck with your algebra, but let's just cheat. It's towards the end of the day, so let's just cheat. Okay, so brackets 85 divided by 258, close brackets, over brackets x divided by 346, close brackets, equals 0.708. And we get 161.006001. 161 is our answer. So alpha is 161. Oh. Again, relative risk. Risk means probability. Relative risk means you're going to be comparing two probabilities, something to something else. This one actually did stop the video and have a think about it. So let's look at relative risk. So the relative risk, so it's doing music for over 4 years versus doing no music, getting NCI, and doing language for over 4 years versus doing no language for over 4 years. Okay, so let's look at the relative risk, and so it reduces it by 30%. So we're going to have to work out the reduced relative risk, which is 1 minus the relative risk. Okay, so the probability of getting NCI, given that you've done language over 4 years, is 42 over 124. It's 4, not a 4, which is 0.339. Probability of getting NCI, given that you've done no language learning, no language of second language anyway. So 130 of those people got it, of 264, which was 0.492. Now, the relative risk is going to be this divided by this. So it's going to be 0.339 over 0.492, which is, I'll use that one for you, so 0.68. Okay, so that means that the reduced risk is 1 minus 0.689, which is 0.311, which is 31.1%. Fair enough. Now let's do it for music. So probability of PCI given that you've done music for more than 4 years is 85 of those people got NCEA out of 285, and it comes to 0.329, and the probability of NCEA no music, so people got NCEA and didn't do music, it's 161 out of 346 people. And that comes to 0.465. Okay, so this is why I did the numbers first to see numbers. Because that means that the relative risk between those two is going to be 0.329 over 0.465, which I get is 0.708, and we actually did work that out. So the reduction is 1 minus 0.708, which is 29.2%. So both reduce by around about 30%, 29.2 and 31.1, around 30%. Where do we get the problem though? When Young decides, so I'll reread it, so that a New Zealand article encouraging young people to learn music and languages quoted the study claiming that either learning a musical instrument or a foreign language for over 4 years when young reduces the risk of developing NCI in later life by 30%, compared with not learning either one. And there's a problem when you're not comparing like with like. Okay, so not learning either one sounds like you're not doing either of them. And also, what if you do both of those? So it's the problem is a problem with conflation. Are we really comparing the same things? Are we comparing the same risks? And outcomes? We're not really. Sort of, but not really. So the person who wrote that article should have kind of go through and explain exactly what they mean by that. There just isn't enough information for us there to make that kind of final conclusive point. And that's the end of this exam. Good luck. All right, I'm recording this on the Sunday before this exam is given on Tuesday. So let's kind of go through the exam, through last year's exam, and see pretty much what we can deduce from that and what you can expect. So this is Level 2 Statistics, 2024. It's the table that they give you. Z doesn't come in the way nicely. Just the way that they scanned it. But it's really important to know that you can use the tables, you don't have to use the tables. I'll show you two ways of using your calculator or using the tables, but use the calculator that most students use, so we'll use that. Okay. And recent survey. Sport New Zealand asked how many hours in the last week that participants had spent being physically active for sport, PE, exercise, or fun. Okay. The results were age 5 to 17 run by physical activity. The mean was 10.8. So you expect from that the mean is 10.8. The standard deviation of 3.2. So it's distributed. Standard deviation. Assume that the distribution is approximately normally distributed. Okay, cool. Then they want you to find what is the probability that a student chosen at random is between 6 and 10.8. And 10.8 just happens to be the mean as well. So there's mean, it's 10.8, and here is 6. So they want that area there. Okay, so a couple of things we could do. We could use the tables. We can use the calculator first though. So we'll go along to our calculator and we would go to stat mode. We'll be doing stats, distribution F5, normal distribution, and we're going to be using NCD, cumulative frequency. So the lower bound here is 6. Enter. The upper bound is 10.8. The standard deviation is 3.2. And the mean is 10.8 as well. The upper is the same as the mean in this case. Put it in and we get 0.4332. And it's 40 centimeters. Okay, so that's if we did it using the calculator. If we decided to use tables and used the equation that they give us there, then we would put the x is 6, the mean is 10.8. We divide that by 3.2 to find the z-score. So I'm just showing you this so you can see how the sausages are made. So 6 minus 10.8 is that should be a negative number. Divide that by 3.2 is negative 1.5. So the negative means it's to the left of the mean. So our z-score is negative 1.5. We would come up here and we would find 1.5, and there we go, 0.4332. It's right there. You can see it. That's how we would do it using the table. Okay, let's just go on then. Find the probability that a randomly chosen young person spent over 16 hours physical activity last week. And we took about the same groups. Yep, so there's the young people and the mean and the median the same. Okay, so mean is 10.8. Standard deviation is still 3.2. And now we're trying to find these 10.8. How many of them are above 16? Let's go to our calculator. Same thing. Distribution, normal distribution, cumulative distribution. And now the lower is going to be 16. The upper, we're going to make some crazy number. We're going to say like 40 hours. The standard deviation is the same. The mean is the same. So 0.0521 or 5.21%. That's it. Okay, if we use our z-score, the z-score that we would get would be 16 minus 10.8 over 3.2, and it's going to give us some number. We can use that number. Just do what works. Again, next question. 12% of all young people are found to do less than the suggested amount of physical activity needed by the Ministry of Health guidelines. What is the minimum number of weekly hours if 12% of people are doing less than that? It's normally distributed. It always helps to do the graph. So this is the mean 10.8 hours of exercise, and we want to find, so that's 0.12, that's the area under there is 0.12, and we want to find out this x. So we know one of the boundaries, or we need to know both the boundaries really. We know the boundaries, we know the parameters, we know the standard deviation is still 3.2. What are we going to do on the calculator? We can use the inverse function. We've got the area, we've got the probability, now we need to find the boundaries. So on our trusty old calculator, we are going to exit out there, exit out distribution again. Now we do inverse. Okay, we're looking for the tail left, so the left-hand side there. We could have the tail. Be careful with the middle. Or we could have the right-hand side. We've got the left-hand side, so we're looking for the bottom. We're looking for the bottom, not 12%, but 0.12. And the standard deviation is 3.2. The mean is the same. So 7.04. So 7.04 hours. So to translate it into English, 12% of students are getting less than recommended units. So it's a math exam with a writing exam. recommended amount of activity, which is 7.07 hours. That's that. All right, so this one is a bit of a tricky one. The results of the survey showed that for year 11 and 12 students, and this is a bit of a distracting year 11 and 12 itself doesn't mean anything, don't extract 11 and 12, age 15 to 17 years, 5% of those students spent less than 30 minutes, that is 0.5 hours, in physical activity each week, for whatever reason. Calculate the standard deviation for the number of weekly hours spent on physical activity by those students. Okay, so the mean that they spent is 8.1. So from that, let's extract the mean is 8.1. Okay. We know that 5%, so 0.05 less than 0.5 hours. Okay, so in our little bell curve we've got, we know that the average is 8.1, and these people here are in the bottom 5%. So this area here is 0.05, and that they spend 0.5. So we've got almost everything. We don't have the standard deviation. Okay, but we do have an equation that ties them up, and it is Z equals X minus mu over standard deviation. Now you might be saying to yourself, well, we don't have Z. Well, we kind of do. Okay, so we've got X is 0.5. We've got mu is 8.1. We don't know that. We need to work out what Z is. Now, here's what I'm going to do. I'm going to go to calculator here, and I'm going to go to stat mode. I'm going to work out the Z score using standard deviation, using the inverse deviation. So, the left tail has 0.05. I'm going to say that the standard deviation is 1 and mu is 0. And that means that I'm going to find the Z score on a standard normal distribution, which is what we want. And it's going to give us negative 1.644, negative 1.6. Negative 1.64485. Okay, so in other words, negative 1.64485 is going to be equal to X, which is 0.5, minus the mu, which is 8.1, divided by the standard deviation that we don't know. Okay, now it's no longer a statistics problem, now it's an algebra problem. So let's multiply everything by the standard deviation and then divide everything by that number. So the standard deviation is going to be equal to negative 0.5 minus 8.1 divided by negative 1.64485. And see how I kept the minus there to keep you on check. The minus will disappear because the standard deviation can't be minus. I've kept the minus there so I know that it's to the left, and I'm going to put that in my calculator and solve it. It's a nifty trick to have. In fact, I might do a video after I've done this one on how to use your calculator. So brackets 0.5 minus 8.1 equals that, and I want to divide that by negative 1.6485. And how about that? Standard deviation is 4.62. 4.6205. Not bad. So why might this not be correct? Well, if we look at it, we have our distribution curve and 8.1, and the standard deviation is what the example is 4.6205. All right. What is the problem that we are going here? Problem is that we have 0 here. So if that were true, if we grab our calculator and do an inverse on that, let's close that. So between negative 20 and 0, so, and the standard deviation was 4.6205, and the mean was 8.1. That would tell us that almost 4% of people do negative. So that's 3. So that's approximately 4% of people do negative exercise. Negative exercise. I think that. Sign me up. I can't do it. So this must be skewed. This would have to have a peak, and then would have to skew out to compensate for that 4%. So two things that disqualify it is that there is an impossible boundary, and it must be skewed because of that. In fact, if you look at the question, 5% less than 30 when the mean is 8.1, yeah, it's going to be skewed. So it probably looks sort of like since this is the students and this is the time, it's probably the 0. So it's probably skewed like that, to be honest. Not that nice bell shape. I mean, this bit here, between here and here, it looks kind of bell shaped, but it did have like skew. Okay. and also the mean and the median. Necessarily. All right. Next question. This one is an interesting one. Since this is for people 75 and over, 45% of the survey of 75 years and over spent less than 30 minutes. Less than 30 minutes in a week in physical activity, and the mean is 4.3 per week. So this is definitely not disputed. Okay, if you have 45% less than half, but the mean is 4.3, it probably means that so this is some hours of exercise. Again, it's probably wrong. Very, very skewed. So that's going to be a 45. If that's 45%, yeah, that's 0.5, and the mean is about yes, then it's going to be very much skewed to the right, skewed positively or skewed to the right. It's more extreme. So these ones we can't do. They don't give us the data. I've looked up this website. There's just a whole bunch of numbers in there. It doesn't really help us. So we can't do this because we need to compare the data, what's in the charts. I'm going to have to jump here. All right, so let's just move on to question 2. Learning a second language is considered a good way of improving your memory. A large study language learning app found the following: 22% of the app were under 18, so it's going to be shown down here. 35 were 18 to 30, and the rest were 30 and over. So it says, yes, we might as well put these numbers in. So what's going to be left over? It's going to be 1 minus 0.35 minus 0.22. So that tells us that 0.43 or 43% are. Then we have to add up to 1. Okay. Of those who were under 18, so 3/4 were learning a language using the app for academic reasons, school or work. Okay. 15% for travel. So that's 5. The remainder were for personal reasons such as family, so we need to work out what that is. Just a complete thing. So 1 minus 0.75 because 3/4 is 0.75 minus 0.15 is 0.1. Enough. For the 18 to 30-year-olds, so here, 1/4 use it for academic purposes. 60% use it for travel, so 0.6, and the rest use it for personal reasons. Well, even if we don't need to do it, it's a nice activity to do. So 1 minus 0.6 minus 0.25, which is so. Let's say this 0.25. Okay. For the 18 to 30. Okay, complete that. That's all we've got is notes. There's nothing about the older people at all. No. Okay, let's complete that. What is the probability that a app user chosen at random, that is starting here, is under 18 years old and uses it for language for travel? So that is this particular branch here. So multiply down the branch. So 0.22 times 0.15 times 0.5. So the probability that the under 18 these travel. Okay, we'll grab our calculator and do its business. So 0.22 times 0.15 is 0033. 0.033. So there's a probability, so they want that as a percentage. I guess you could say that that's 3.3%. Tentatively correct. Out of a randomly selected group of 40 students, how many would you expect to be aged 18 to 30 years using the app for either academic or travel purposes? So randomly selected from the beginning, how many would we expect to be between 18 to 30 and academic and travel purposes? Okay, so we need to work out the probability of both of those. So this one and travel, isn't it? So this one here is going to be 0.35 times academic, which is 0.25, plus 0.35 times 0.6. Okay, use the calculator. So the probability of them being either of those, we've got it right. Academical travel, 18 to 30, correct. Okay, so brackets 2.35 times 0.25 plus 0.35 times 6. Is that 0.2975? So for this one here, we're really wanting the expected value. And the expected value x is the probability of x happening times the number of trials. In this case, the number of trials is 40, and the probability that we worked out before is going to be 0.297. So this probability there is going to be 0.35 times 0.25 plus 0.35 times 0.6, which is travel equals 0.2975. Okay, now we want to know how many we expect. So it's going to be this number times 40. So the expected value is going to be 40. It's going to be 40. 40 times 0.2975. 11.9. So 11.9, but we can't have really 0.9 people, so we'll say approximately 12. And that will be a good enough answer for that. All right. This next one is a little bit tricky. So let's just read through it. So the app results, the survey results were shown of the app users over 30 years of age, and that's that bottom branch, 3 times as many use for travel than for other reasons. Now it's not really that well worded because there are 3 options. There is work, work in school, travel, and other. The way they do it there, it makes it sound like the other two are other. In fact, they mean that. Okay. Now, they tell us overall 55% of all users intend using it for travel. So let's go back and see where we're at with this 43% of people who are over 30. It doesn't give us information, so we need to work that out for ourselves. Okay. So if 55% of all users, that means that, so these are for the young users, they call them the 18 to under 18. Okay. So these are less than 18. So under 18s who do travel, it's 0.22 times 0.15. We add that to the 18 to 30s who do travel. So that would be 0.35 times 0.6. And then we would add the 30 pluses here, and we know that they are 43% times probability that they travel. We don't know that, but we know that when we add them all up, we get 55% of users, so it must equal 0.55. And now it's a matter of algebra. So let's do the algebra, even though we've done some of this algebra just now. Times 0.15 is 0.033. 0.35 is 0.6, and 0.21. Okay, and plus 0.443, and we'll cause T for equals. Okay, so let's bring it down. So 0.43 times probability that they travel. It's going to be equal to 55 minus those. 0.21. It's 0.033. 0.307. Okay, and to find t, it's going to be that number divided by 0.43. And so 7714. So the probability the person who's over 30 travels is 0.71. Okay. So how does that help us? Well, it helps us a little bit. So it says that of the app users, 3 times as many people using travel. Of the 30 people over 30, 3 times as many people use the travel than for other reasons. Okay, therefore, other reasons, so over 30 and other reasons must be 0.714 divided by 3. And it's still a calculator, so we'll just 0.27. 0.238. Okay. What is the probability that they use in the app for work? Well, it's going to be 1 minus this 0.714 minus this 0.2380, because they'll be paid to do something. 1 minus 0.74 minus 0.2380 for 0.048. They're doing it for other, given the fact that they're over 30, is it's at its own. Okay, so for this one, we need to use the information that we've already got from the probability tree, only apply it to 18 to 30-year-olds. So it's estimated that about 10% of 18 to 30-year-olds finish the course if their main purpose for learning is academic purposes. 6% will finish the course of that same lot if their main purpose is travel, and 2.5% will finish the course if they just have some other reason for learning the language. So if we take the node here for all the 18 to 30-year-olds and just ignore the rest of it, there were 3 branches. There was academic, there was travel, and there was other. And we already worked out the probability that this academic was 0.25, 60%, 0.6 to travel, and we worked out it meant that 15% did it for other reasons. Now we can add another branch, fail, once they fail, but finish. So This is finish, not finish. Finish, not finish. Finish, not finish. I don't really care about the not finish, but so the probability if they if they're academic, they say that it's 10%, so 0.6% of 18 to 30 users did it if they did it for travel, so 0.06. Really, it's really sad. And 2.5% finished if they did it for any other reason, so 0.02. Okay, so what is the probability that if a user aged 18 to 30 years is chosen at random, so we're back to that node there, they finish the course. So let's kind of add these together. So 0.25 times 0.1, and this is going to be 0.6 times 0.06, and this is going to be 0.15 times 0.025. And add them together and get an answer. And that 0.25 and 0.1, close brackets, plus 0.6 times 0.06 plus 0.15 times 0.025. That the probability they pass is 6.475%. Zero 647. Not great. Look at that. What's that? What's that? What's that? Ooh, that's some good. Not a great school, but looks of it. Okay, fair enough. Should do maths. This one is a bit sticky one, but let's look it through. So if we read it through, according to the promoters, the language learners who buy the premium, there's always a premium option, are 4.2 times as likely to finish the course as standard users. It is known that about 5% of users do actually use the premium version. It is estimated that the probability of a user chosen at random being a standard user who finishes the course is 3.8%. So let's divide our world up into two classes of people. So these are the premier users, and these are the non-premier users. We know that the premier users are only 5%, so it's going to be 0.05. And the non-premium users are going to be 95%, so that's 0.9. Okay. Then it tells us that the probability that a person chosen random as a non-premium user, so a standard user, it's standard, and they pass Finishes. Yes, probability of a user chosen random being standard user who uses that is 3.8%. So that's 3.8% in the end, which is 0.038. So this is finish, this is not finish. Okay, so 0.98 times what gives us this? And we'll call this capital. So going down the branch, so 0.95 times f equals 0.038. Okay, and f is going to give us the probability of us passing once we've decided that it's standard. So f now is going to be 0.038 divided by 0. Instagrams to death, if you can hear it. But 0.38 divided by 0.95 is 0.04. So 4%. Which means 96% you don't pass. Okay, and then they tell us that a premium user is 4.2 times more likely to succeed. Yes. Okay. So 4.2 times 0.04 is 16%. So we're almost there. Almost there. Now we have to work out. We have to work these out. So, what is the probability of finishing the course? Okay. So it's going to be that plus RE1 there. So it's going to be 0.05 times 0.168 plus 0.95 times 0.04. It's going to give us our answer. We can't already read that bottom one out. Let's do it. And the answer is 4.64%. 0.0464. So if you were 4.2 times more likely, you've got a 16.8% chance. You need to buy a premium pack, and if you buy the all right, well, let's crack on with questions. We're almost there. The tables. Many researchers have found that playing a musical instrument or learning a second language can help some people mentally active, keep people mentally active. One longitudinal study, longitudinal means conducted over a long period of time, in 2015 found that 964 healthy older participants, 60 to 75, were asked if they learned a foreign language or studied music before the age of 18. They were then monitored to see if they developed mild cognitive impairment, NCI, over the next 6 years. Right. What percentage of participants developed NCI? Well, all of these are all comparative, so it's always something over something, and it's going to be our total, 964. How many actually developed NCI? It's the same year, so it must be 396 out of 964, so it's a good job for calculator man. So 396, 396. Come on, come on. Here we go. 396 divided by 961 is 0.4. So approximately 41.1. What is the probability that this participant developed MCI if they had learned a language for at least some time? Okay. So, people learned a language over that time. That's going to be that's 700. Yeah. So 576 plus 124 is 700. That will be developed NCI. Yes. So it's going to be this divided by this, isn't it? So 224 plus 42 over, I didn't make before, so it's 700. So 576 plus 124. And that's going to be the fraction and to the percentage. So 224 plus 42. So these are the people who got it and did the language learning divided by 576 plus 124 is that. It's exactly 0.38, which is exactly 38%. So 41% in the general population versus 38% in the population that learn the language. Okay, that's interesting. Okay, Susie looks at the tables of data and says it is twice as likely for people to develop NCI if they learn music over 4 years than if they learn a language for 4 years. So let's look at the numbers. So language over 4 years is 82. So what did she say it was? She says that it's twice as likely to develop NCI if they learn music over 4 years than if they learn a language. Okay. 42, 42 who learned the language got it, and 85 who learned music got it. But we took them in different scales though. Okay, so guess her I guess her logic is I guess her logic is that 85 divided by what is it? 2 equals about 2.2 and a bit is about 2.02 an absolute number. Right, but we're looking at we need a proportion. Because there are way more people did way more people did whatever the A was. Yeah, way more people did the music than the language. So correctly, we want to find the probability that they get NCI, given that they've done language over 4 years, versus the probability that get NCI, given the fact that they've done music for greater than 4 years. So we're in years, so 124 and 258. So language is out of 124, and that's out of 258. And we know that 42 of those people did here versus 5. So 42 divided by 1, 2, 4. 33.9% versus 5 divided by 258, 32.9. So you're actually less likely to get it if you do music. So she's wrong. Okay, for this one,